Okay, so for Chapter 7, we're talking about systems of linear equations. And the first question in our review here is going to be asking which linear system has these solutions. So x equals 1, y equals negative 3. When you look at this on a test, what you're probably going to want to do is you're probably going to want to just check the first equation of a few of them to narrow things down maybe. If something doesn't work out, stroke it out as an answer, right? If you want to do a formal work it out, that's great. If you can do the first part at least, just mental check, that would be awesome. So for example, what I'm saying is this. Check A right here for x equals 1, y equals negative 3. In your head, you probably could say 1 plus negative 12, right? You can do that. 1 plus negative 12 is 1 minus 12. Thank you. And this one's going to work. Okay, so it could be this one. You're not stroking it out right away, right? Over here, 1 minus 6. That doesn't give us 1, right? All right, so C, looks like we could stroke C off right away, right? All right, now you could do another quick check on these ones here. 1 minus 9, okay? Positive 1 minus 9 doesn't give us negative 10. Negative 1 minus 9 would, so this is a no good, right? So 1, 2 times 1 is, so that's 2 minus 3 is positive 1. 2 minus 3, that should be negative 1, right? So it looks like we're going back to here, and let's just check the second one to make sure, right? And again, I will do this now. I'll just show you the work here if you're wondering what I'm doing. So the first equation would be 1 plus 4 times negative 3 was negative 11. That's 1 minus 12, negative 11. That's good. The second one, 2 times 1 plus 2 times negative 3 equals negative 4. 2 minus 6 is negative 4. Oh, that's great too. So here A is your answer. Now, I would suggest this is the way to do this kind of question. Obviously there's other ways you could do it. Like you could rearrange all of these equations into y equals mx plus b. You could graph them and find the solution. That's going to take you forever. If you don't hit the right one, that's going to take you 10 minutes. You can't spend 10 minutes on one question. So this is probably what you want to do. Okay? Got it? That's how you tackle this question. Don't graph it. Don't do tables of values for all of them. Don't try and find which, you know what I mean? There's ways you got to kind of be efficient here. And for you guys in grade 10, as you move through, you got to choose efficient ways of doing these things because you can't, you don't have an unlimited amount of time to do all these questions, right? This isn't a weekend project. This is an hour exam. Okay, got it? Okay, let's move on to the next example here. And again, I wouldn't copy this down, probably. We're not going to have, there's a lot to copy down. So just watch and just pay attention. You should be able to get this. Okay, so it says create a linear system to model this situation. All right, so again, this is a multiple choice question. So you do have some answers here. I wouldn't suggest trying all of these answers maybe, but what I would suggest is trying to get an idea for what you think the equations would be and then go from there. So it almost would be easiest to write down your equations and see which ones match up. But let's just go through it. Sherry operates grass cutting business. She charges $18 for a small lawn. Wow, when you see something like this, 18 for a small lawn, that's like 18S. That's what that screams out to me. Okay, $18 for every small lawn she does. 28 for the large. Boy, that looks like a 28L. So we have S's and L's here, so that's great. One weekend, Sherry made $218 by cutting 11 lawns. Okay, so she cut 11 lawns. So that's S plus L is 11. So S plus L does not equal 218. She didn't do 218 lawns. She didn't do 218 lawns. Okay, she did 11 lawns. So which one, A or C, looks like it might be the one? 18S. We got to have 18S in there, not 28S. So again, this one is A. All right. Yeah, you can clap for yourselves. That's great. So the grade 12s borrowed my "that was easy" button yesterday. So I don't have "that was easy." That's what I'd be doing right now. That was easy. Like that. Does it sound like? Does it sound like? Yeah. Okay. So that's good. All right. Okay. So let's go back to my Schmancy test here. Okay. So I have this is an actual test. This is just kind of a review assignment that I just made up here. Okay. Let's take some time on this one. I think this is a good one right here. So let's clip this one into the old. Hello. Again, don't have to write this one down. Just sit and listen, relax. This one is not an active sort of copy down one too much here. But I'll show you. Okay? So match each situation to a linear system below. So again, we're practicing writing equations. This is still early on in the chapter, right? The perimeter of a rectangle playground is 164. Okay, perimeter, rectangle. Awesome. You can jot that down if you want. But we have width, we have length, we have width, we have length. So 2 widths plus 2 lengths has to equal 164. Okay? That looks like all of them here, right? 2 widths plus 2 lengths. Okay. All right. The length is 6 meters less than double the width. Okay, here's where it starts to get tricky. I would write things down to make sure that it makes sense. So the length is 6 meters less than double the width compared to double the width. So the length compared to double the width, the length is 6 meters less, okay? So you're going to have to do a plus 6 over here or a minus 6 over here. Do you see that anywhere? Right here. So it looks like A goes with number 1. Does everybody see that? And once again, this is super important. The length is 6 meters less than double the width. This is not L minus 6 equals 2W. It actually isn't. Because the length is less than double the width. So that means that you have to add 6 over here, or you have to subtract 6 from the bigger one. Does that make sense? Okay, so A goes with 1. So if you want, again, if you're writing this test, you're going not B, not C. Right? Get rid of those right away. So let's go to B. The perimeter of a rectangle, 64. Okay, good. The width is 1/2 the length, decreased by 6. The width is 1/2 the length, decreased by 6. The width is 1/2 of the length, decreased by 6. That one you can just write straight out. So is this one here anywhere? Okay, and yeah, 1/2 the length decreased by 6. That would work with this one, right? So B is going to go to number 2. All right, there you go. That one's gone. A. You don't even have to check C, right?
Where does it go?
Huh? Hey, you got braces today.
Oh,
Are those new?
yeah.
Oh, cool. Okay. Yeah.
I don't
It's just like a big reflection when you look over. It's like your teeth were twinkling there.
Yeah, there's my teeth like this.
Okay. All right. So any questions about that? We can check C too. But hey, if you're on a test and you've crossed out every other response, just go with A. That's good. This is enough. Okay. I'm not trying to rush you through the test. I'm just trying to help you be efficient. Okay. Questions? Use the graph to solve the linear system. Okay, well, here's the linear system. They give you the graph. This is as easy as it gets, right? This one. The solution to any linear system when we're looking at the graph is the point that is the what? It's the intersection. So all you have to do is you have to look at the intersection point here. That's 0, -2, right? This one is D. Okay? Got it? All right, easy. Easy breezy. Okay, let's keep going here. Oh, some more graphs. Okay, big deal. Let's take a look at this one. Okay, look at this. This question here, big, long, ugly question, right? Not really. Why? Because they give you the situation, they give you the equations, they also give you the graph. So this is like all this work is done for you in this question. This is not a big, ugly question. And the question actually says, how many students use the skating rink on Tuesday evening? Okay, so let's see what the graph says. Number of students, number of adult admissions. Okay, all right, we've got 2 lines. So we got to read a little bit more because it's not strikingly obvious, perhaps. But it says Tuesday, 24 people used the rink, 120 fees were collected. Here's the situation. S is the number of student admissions. A is the number of adult admissions. Use the graph to solve. How many students? Okay, so this is all about Tuesday right here. Okay? How many students use the rink on Tuesday evening? Okay? And the solution to this whole thing is going to be still the intersection point, right? So the number of student admissions, what you'd want to do is try and find out, right? Try and find out what number on the x-axis this would be right here. So you're going to have to get, oops, you're going to have to, we'll zoom in there a little bit. Whoa, where'd it go? I zoomed in a lot. Zoomed into the wrong question. Awesome. Okay, let's get back to this thing here. There we go. So number of student admissions. So you're going to want to try and find out where this is. Again, as best you can. This is 10, 15, and 20. So it's between 15 and 20. It appears to be,
17.
yeah, about 17 or 18. So do we have anything that's close to that? Which one's closest? Right here, 18. Okay? Is that good? Now, I would definitely encourage you to read through the whole question. But what I'm saying is that this is not a question where you have to create the equations, draw the graph, and all this stuff. It's all, a lot of it's been done for you. Okay? Questions? Oh, let's go to that. What was I at? Oh. All right. Okay, so I think what we need to do is we need to get into some of these. Okay, well, here's a question. You're going to have to express each in slope-intercept form. Okay, that might be a good one for us to do here. Let's do this one together. Make sure you can change forms, right? It's pretty important. So slope-intercept form is y equals mx plus b, right? And the only thing you have to do is you have to rearrange the equation so that y is all by itself and positive for each one. So here, y is kind of tucked away here inside, multiplied by this fraction. We also got an x over here we got to get rid of. So let's get rid of the x first. Let's get everything outside of the y term, get everything away first. So this is going to be 6 over 8y equals negative x minus 83. See how I took this over to the other side? So now you're going to multiply by 8 to get rid of the denominator. So everything gets multiplied by 8, right? And how you do this exactly is up to you. How many steps you show and all this sort of stuff, how you think about it. This is the way you can get the answer here, okay? What's 8 times 83? 640. 664? Minus 664. Okay? Now we need to divide by 6. Right? So negative 8 over 6, that could be negative what? 4 over 3, I think, is the simplest form. 664 over 6. Obviously, it's okay, so 332 over 3. I don't know, 332 over 3. I don't think that simplifies. So again, it's, oops, over 3. So it's, this is a short answer, I think, right? So again, once you start doing this, you can start kind of knocking off some answers. So which one looks good so far? This one, B? Right? So B and, okay, C and D. So not A. Okay. So then you just go ahead and solve for y for the other one too, which I'll do quickly as well. Okay. So the second one, let's get the 12x over to the other side. And then we'll divide by 4. 1196 divided by 4 is 299. Okay, so it looks like this is your other one. Do we have that one in there too? D? Okay, so it looks like D. So solve for y in both cases. There are your 2. And D is going to be your option there. Okay? So that one you do just kind of have to rearrange things. Okay? I won't give you questions like this with the tables here, I don't think. I mean, we didn't really do questions like that, so it's something like that. Okay, let's do a substitution question. And we'll do an elimination question, and then we'll be done sort of our review, okay? Or our official teacher-directed review anyways. Clapping for that?
Yeah.
That you want me to be done?
No.
Okay, this one you need to write down. Write this down so you know you can do it. Actually, what I'm going to do is I'm going to give you a minute here or two to do this yourself. See where you're at here the day before the test. Substitution. What do you remember? You can go ahead and look back to your notes if you want, but take a few minutes to just a couple minutes to do that. See if you can do it. Okay, so let's just revisit this here. So this x is already isolated for. We want to put that in to the other equation to get one single equation. Okay, so yeah, I just need to change this to a plus here. Okay, so 228 plus 132 is going to be what? 360. Okay, so what's y going to be equal? What is it? Thank you. All right, so once we have y equals 15, then you can plug that into either one of the original equations. That's the last step you have to do for the substitution. So it doesn't really matter which one. I'll go back to the original, the first one here, I guess. It's fine. So plug all that in, and you get x equals 30 minus 22, which x equals 8. Okay. So then let's check. Sorry? Is that good? Missing anything? Question? All right. All right. So to check, let's check both equations. All right. So obviously, 8 equals 2 times 15 minus 22. We just did that one. That's good. And the second one, 6 times 8 plus 12 times 15 should equal 228. Okay. So 48. And what's 12 and 15 then? 4, 6, 80. 180? 228. And that is true. Okay, so there are your answers, and that one was a multiple choice, right? Now, if you want, like if you get I don't know, that would probably be the best way to do is actually do it and get your answers. However, if you get an answer that doesn't show up here, right? Let's say we did something wrong, like I made that error with the subtraction here. So let's say I get two different answers. The nice thing about multiple choice is, right, is that you're going to see the answer is up there. So if you get an answer that doesn't show up there, now you got to either start over the process, or what you can do is just say, okay, well, I think it might be this one, so you can just quickly plug these values in, right? There's the x, there's the y. Just see if those work. You can plug these values in to see if they work too. Okay, that's fine too. So 8 and 15, so that would be the one, so C is your answer. Yes?
For questions like that where it says use substitution, we have to show our substitution.
Yeah, you'll probably have to, like on the test, you'll probably see show your work for full marks. So if I don't see any work, you probably won't get full marks. So you're going to need to show some work there. So when it says, like, that's a good question. When it says use substitution, you have to use substitution. if, like I say, if you get the wrong answers and you just need to go back to substitute things in, if your work doesn't match up with your answer, you probably won't get full marks, but you'll get marks for the right answer if you can get the right answer. Okay? Usually on multiple choice, there's no credit for the work, right? But on this test, there will be some credit for your work for questions like this where you do need to show some work. Yeah.
So would we just put in like one of the equations and then write in the numbers? Do we have to actually figure it out without?
Well, okay, so this question says use substitution to solve. So you will have to, there will be some space here for you to show your work on the paper.
So we can't just plug in those numbers?
Not for these ones that get, you can do that, but you won't get full marks. If it just says solve anyway, and you want to just start plugging values in, then go ahead. But this one does say use substitution, so yeah. Okay? So there is value for the right answer. In multiple choice, unfortunately, a lot of times it's not a lot because you can guess, right? Like, I mean, do you know what I mean? So you kind of have to be careful. Sometimes there's part marks available, sometimes there's not. Okay. Okay, this one looks like a tough one. Let's use elimination strategy here. And this one's got some fractions, so let's copy this out. Okay, elimination. So, again, most students, I mean, I don't like working with fractions a lot either. I mean, we can, but it's a good idea to try and get rid of the fractions so you deal with the whole number coefficients. It's usually just generally a bit easier. If you don't mind adding fractions and stuff, and that's fine. But I would suggest that you get rid of these fractions by doing one simple multiplication at the beginning, by 12 here, and by 8 here. Now why 8 over here? Because 8 is a multiple of 2 and a multiple of 8. That's the lowest one. So you're going to get the lowest numbers, right? Okay, so 12 over 3 is 4, times 2 is 8. So that's going to be 8m. 12 over 4 is 3 times 3 is 9n. And 12 times 16, let me say that, 192. Is that right, 192? Check my mental math there. 12 times 16. 8 times negative 1/2 is negative 4m. 8 times 3/8, that's 8 over 8 is 1, so that's just 3n. Equals 8 times 18 is what? 144. Okay, so assuming all these multiplications are correct, did anyone double check me there? No? You trust me. Oh, thanks. You shouldn't. No, you shouldn't. You need to check this out for yourself. Okay, so linear systems solving by elimination means that, okay, first of all, you want to make sure that your like terms from both equations are vertical like this, right, on top of each other, including the equal sign. That just makes things a whole lot easier, so that's already like that. That's great. And then what you're going to want to do is you're going to focus on the coefficients of these like terms. And you're going to try and get a number that's exactly the same number but opposite sign, right? So you have two options here. You can multiply this one by 2 to eliminate the m terms, because that's going to give us a negative 8 and up here a positive 8. Or if you want, you can multiply also this one by negative 3 to eliminate the n terms. Either one's fine. Either way will get you the same correct answer if you do everything right. So let's do this one. And this is then going to turn into negative 8m plus 6n equals 288. And so that equation is now gone. I'll just stroke it out. And now what we want to do is we want to add. Because when I add now, 8m plus negative 8m, that's gone. There's nothing there. So you just leave that blank. 9n plus 6n, those are like terms, so we can just gather it into 1. That's going to be 15n, right? 192 and 288 is going to be 380.
480.
Thank you. 480. See? Michael? Don't trust me. Don't do it. Okay, divide by 15, both sides. What do you get? What'd you say? 32? I think that's right. I'll trust you. No, I'm going to double check it. No, just kidding. All right, so 480 divided by 15 is, wow, you guys are great. Okay, so n is 32. Awesome. If this was a multiple choice question, which I actually think it was, you could kind of start to X out some things there now, right? Cross out some possible answers. Wait, is that the one right there? Did I copy it out correct? Negative 1/2. Oh, n is 32. Yeah, okay. Is it positive 32? So there's only one answer that has a n equals positive 32 then. Okay? Now, just wait. You're going to want to double check that m equals negative 12 somehow. Okay? And if this one says use an elimination strategy, you really need to finish it off here, which is only one more step anyways. So take 32 and plug it into one of the original equations. Okay, let's do the second one here. All right. And so 32 over 8 is 4, times 3 is 12. Negative 1/2. M equals 6. So times negative 2 here will get us m all by itself. M is negative 12. Okay, so if you have a negative 1/2 m, if you multiply it by a negative 2, then you get rid of the fraction and the minus sign, and you have just m. Okay, so negative 12. So is that, here we go, A. See that? A. Elimination, substitution. Okay. So let's do one more question here to finish this Chapter 7 review using the graphing calculator to solve. Okay? So let's grab a graphing calculator. So on your test, you want to make sure that your calculator has batteries, A. Okay? Go to the y equals section and clear each entry for the y equals. Make sure your screen looks just like this. These plot 1, plot 2, plot 3 cannot be highlighted either. Okay, so if someone's using these for other classes, they may look like this. Go up and click enter on that to deselect it. Okay, it's got to look like this. That's the first thing you want to do, and we'll do that at the beginning of the test probably. Now, when you get to a question that looks like this, it'll say use graphing technology to solve this linear system, where necessary write the coordinates to the nearest tenth. You also might see a little instruction to sketch your graph, a rough sketch of the graph on the paper. I just want to see that you've actually sketched the graph. It doesn't have to be a careful sketch. You don't have to use your table of values or anything to like make it exact. Just a rough sketch, and I'll show you exactly what I mean. So you're also going to have to do this. Now, we cannot put these equations into the calculator as they're written right now, right? We have to do what first? Who remembers? We have to solve for y. So let's get to y equals mx plus b. Okay? Awesome. So the first one, thank you. The first one looks like this. So we got to solve for y. Let's get rid of this over to the other side. Doesn't matter what order things are in. Let's divide by 3, right? Everything divided by 3. So that's negative 1 plus 5 over 3x. Again, doesn't matter the order. If you want to write the x term first, then you go right ahead. Second one, 6x plus 8y equals negative 6. You can simplify this, but again, the calculator doesn't care. We're just putting it into the calculator. So the calculator does not care if this is simplified. So I'm just going to use those two. Are you guys okay with this first part here? Like getting this and this, and does that look correct to you? Remember, double check my work here. We're all in this together. I passed this class a long time ago, so yeah. So it's, you guys got to be sharp for tomorrow. All right. Okay, so let's put these in. Let's put this one in first. Okay, when you're dealing with fractions, another good. Okay, there's two things important here. If this right here is a negative sign, if it's at the beginning of an expression, you have to use this negative here. If it's a minus, like over here on the 6, 8, this is a minus. That's a negative. Negative and a minus. The calculator does care about that. So you got to do that right or else you get an error. So plus. Second thing, when you're using a fraction, use brackets. 5 divided by 3, bracket. Then put the x. So yeah, that should be a 1 there. 1 didn't hit. Okay. So it should look like this. Negative 1 plus 5 over 3x. Good? So the next one here, it's negative bracket 6 divided by 8 bracket x. Then you hit the minus button, bracket 6 over 8. If you don't use the brackets, the calculator might subtract 6 and then from that whole thing, then divide the whole thing by 8. So you just want, brackets are usually a good idea. Okay, so I think that looks good now. If I double check here. All right, so now you hit graph, right? Oh boy. This could be good, this might not be. Your window might be all messed up. I don't know. What do you do to get back to a standard window? Who remembers that? Zoom 6, good. Zoom 6. So that gets you to a, 10 to the right, 10 to the left, 10 up, 10 down. So that's good, awesome, look at that. So we have our intersection point there. You don't have to zoom in if you don't want to, but now you have a ballpark of where that's going to be. So at this point you would quickly just sketch that on the paper. Remember, it asked for a sketch. So literally it's just like this, guys. Just draw what you see. Oops, what am I doing? So just draw what you see there. That's all you need to draw, okay? Just so I can tell that you've actually done this on the calculator. That's the way I can tell, okay? Does anybody have any issues with the calculator? Say. All right, so when you have to be able to see the intersection point in the graph, guys. Okay, if you can't see it on your screen, it's not going to work. Now what you do is second function trace, which is the calculate menu. Okay, and in the calculate menu, you want number 5. It'll go back to the screen automatically when you hit intersect, and it'll ask you, is this the first curve? This the first equation? Yes. Is this the second one? It'll show on there. Yes. Do you want me to guess the intersection point? Yes. So it's just enter 3 times, really. And then it'll show you the intersection point. So this is not an exact value, is it? It's an approximate value. So you would write this down as a solution. It says to the nearest 10th. So x equals 0.1, y equals negative 0.8. Or 0.1 comma negative 0.8. That is your solution right there. All right, once again with the calculator, y equals, type in your 2 equations on 2 different lines. Zoom 6 gets you to a standard window. If the numbers are really large in one or both of the equations, you might have to extend your window. Either zoom out, enter, or adjust manually the y and the x so you can see the intersection point. Okay? Second function trace to get to the calculate menu, number 5, and then it's enter, 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 because we only have 2 lines and only have 1 intersection point, so the calculator will know what you're talking about. And there is your answer, your solution. Okay? Any questions?